In this session, we are going to talk about standards and protocols. So, in the last two sessions, in the first session, we had an introduction to internet work. Then we also had a little bit of in-depth into what all are the different types of devices that actually makes the internet. The link to both of those videos will be put here. But in this session, we are going to talk about standards and protocols. But before we dive into what all are the standards available, protocols available, first, let's understand why there was a need of standards in the networking. So, what, as you already seen in the last two sessions, especially in the second session, there were a lot of devices that are actually making this internet. We have seen that there are routers, switches, firewalls, load balancers, access points, many devices. And when the internet was actually available to the public, what happened was it became a big opportunity for the companies to build those networking gears. And when each of those companies build some of the networking gears, what happens is everybody build the networking devices in a specific way they feel is the right way to do. So when the devices want to communicate with each other, what happened was there was no strict language that was actually put in place. For example, let's say you are an English speaking person, and then you are actually put in let's say France to speak French. So now the people in you will not be able to communicate with the people in France unless you know French, right? So what we needed was there should be a standard way, a standard method of communication, so that when somebody speaks, when some devices actually speaks a different language, we should be able to understand that. So think I don't get a better analogy rather than that different languages speak by different people from different nations. Now if they wanted to communicate with each other, then what they would need is to have a common communication language. And the standards and protocols needs to be there in the place. A standard set of algorithm needs to be in place, because at some point we clearly understood that this is going to be very important, because otherwise different vendors are going to build their devices in a way which they feel is the right way, and then it ends up in a state where it doesn't communicate to each other. And as we have seen, all these different, and it's impossible for one vendor to build all the devices in the internet as such, and hence the need of standards came in the internet working world. You can see a simple example here. Again, I think I have talked about this all already. There will be people who are sitting in different parts of the world, and this entire internet is actually built through a set of devices, and all those devices should be effectively able to communicate. For example, let's say this guy who is actually sitting here is connected to the Wi-Fi, and that Wi-Fi goes to the internet routers, and then that means the internet router should be able to communicate to that router properly. The internet router should be able to communicate to the Wi-Fi router properly. Wi-Fi router should be able to communicate with the PCs properly. So if we see, and also finally, when the packet goes to the internet, there are huge routers, firewall, load balancer, everything which is actually sitting in the internet. And finally, when the packet gets delivered to this particular application, that application should be able to uh, understand, first of all, it should be able to accept that message that has come all the way from this user through the internet, and then you should be able to process it and then give a response back, which means from your laptop all the way to the internet, all the devices that are actually in the internet, all those devices and your laptop should be able to speak some common language that actually being understood by everybody, right? And we will get into more details, but this is just an introduction on why actually we need the standards. If you don't follow the standard, what happens is then some of the devices that are actually sitting in the internet, they don't understand what this guy is actually talking, and then they kind of ignore. The same analogy that we actually told earlier, like what happens when you are a person who is in France and you are a person who is actually speaking English, and both of them doesn't know the language each other, then what happens is we kind of ignore whatever that guy is actually saying. So that exactly same thing happens to the devices as well. The devices start to ignore, and then the communication never get established. So that is the real need for the standards to be in place. And this is an elaborated version of when you double click on that glob. This is how the internet will be filled with, and it could be same type of device. It could be a router from say Cisco to a router from Juniper, or router from or a firewall from Palo Alto. This doesn't matter what type of device it is. The communication for the communication to happen between an end PC to the server and back, there are a set of standards that they need to follow. Again, we talked about this. This is a combination of multiple vendors and and if you are having different protocols, then it's not going to help. So that is where the need of the standards comes in. So these are the two major standards that we are actually standards and models that we are actually going to understand in deep. One is the OSI, Open Standard Interconnection, and another is TCP/IP. We will mostly prevalent now is the TCP/IP. We will but also know about the OSI models as well, and then we will see how these standards has been structured. So you can see here it is been layered into 7 layers, and it is actually put in exact order like this, starting from physical, data link, network, transport, session, presentation, and application. Now what happens is, as I told you, the standard has come into place so that the devices that are being built by different vendors in the market, they actually know how it should be built, so that those devices that are being built by the vendor will be able to interoperate with the other devices of other vendors as well. Now, depending on the type of device that you make, it actually falls in one of these layers. So for example, if you remember, we talked about hub. Hub actually goes into the physical layer. And if you remember, we talked about switch, which actually learns about the MAC addresses and stuff like that. That actually goes to the layer 2, which is the data link layer. And if you remember, we talked about the transport layer protocol, sorry, the network layer, and that is where the router actually comes in. And depending on our type of the firewall that you are actually using, it has to know the transport plus application layer, all of the way up to the application layer. So it really depends on the type of the device that you actually use. It falls into one of these layers in the OSI layer or in the TCP/IP layer. So let's first understand what each of these layers are, and what is the job or responsibility, or what all are the standards that need to be that are in each of these layers. Let's start with the application layer. So in the application layer, these are some of the things that actually application layer does. What application layer does is it is responsible. The set of applications that we actually use today lies in the application layer. It could be nested application. Like when I say nested application, that means it actually runs on another application. For example, Facebook, Spotify, Netflix, all these actually runs on the HTTPS. So for a simple example would be, let's take the example of HTTPS or FTP, where you do a file transferring. All those comes under the application layer. So how the application basically defines how the application should work. For example, HTTPS is having a set of protocol standards that actually tells you how an application should behave. Now, next comes the presentation layer. In the presentation layer, what we actually talk about is how the data needs to be presented. For example, let's say if we are actually running a web server and you are actually having an image that is actually attached in the web server, in the web page. So how that image should be represented, what should be the type of image that it should be. It should be IMG image, or it should be, if it is a video, it should be MP4, or if it is a text, what encoding that text needs to have. Those kind of information are actually fed into the presentation layer. Then comes the session layer. The layer is responsible for encrypting the quality of services. If there are multiple requests that's actually coming to that PC or the server, then synchronization between multiple requests. Those are the set of responsibilities for the session layer. And then comes another layer called transport layer. In the transport rail, it actually decides like which port to listen to and what to carry the data. So basically, in the transport layer, what we have is we are in the transport layer. We have we have something the concept called port, which is a specific number which actually varies from there is a particular range 0 to 65535. That is a total number of that is a specific number of port that you can actually use. And at the transport layer, you will be listening to that particular port. A service will be listening to that particular port so that it makes a connection from the client to the server. We'll talk more about that in coming sessions, but just remember that for the transport layer, it actually decides which port to listen to and what type of data to carry. There is two different protocols majorly that we will be talking about, but we'll dive deeper into that. And in the networking layer, what it does is it actually decides how to send the packet when the packet has originated from the PC. And in our example, if PC goes all the way to the application somewhere in the internet, it actually decides how do you route this data from that client to all the way to your end application. That's the responsibility of the network layer. And at the data link layer, the next layer which we are talking about, its only responsibility is it. So there are segments of the network. For example, when there is a PC attached, and that PC will be connected to the switch, and then switch will be connected to the router. So that segment on how this packet needs to go from that PC to the next immediate hop, which we call about, which we will talk about default gateway a little bit more later. But how the data link layer is only responsible for sending that packet or the message from the PC to the immediate next hop. So that is the responsibility of data link layer, and we will take an example and then go through this in detail. And the physical layer, finally, the last layer where you plug in the cable, or if it is a Wi-Fi through the signal the data goes. It's all signals, ones and zeros. The entire data that has been generated by the application, defined by the presentation layer. In the session layer, it actually synchronizes that if there is any quality of services or encryption needs to be done, that will be done at the session layer. At the transport layer, you're going to there will be a port through which the message is actually generated. If it is a server, it will be listening to a port. And in the network layer, it decides how to route the packet finally to the destination. And the data link layer says, okay, my only responsibility is I will send this packet to the immediate next to the immediate next node in the network through the link. And the final, in the physical layer, it says converts those things in that it has got from the data link layer into ones and zeros. One of the rule of thumb is any protocol or devices that is actually lying in one of the layer, it will and can use the services of the below layers, and it cannot use the services of the above layer. What that means is, let's say there is a device or a protocol or anything that is actually coming in this transport layer, it can use any of the services in the transport layer or any of the services from the network data link layer or the physical layer. It can call those services, but it cannot call the services above it. So just remember that rule of thumb. Now let's go over and then understand some of the protocols that are actually used. And here, if you can see, this is how the OSI model and TCP/IP model are actually used. With the application layer, presentation layer, and session layer combined into one thing called application layer. And the transport layer, is mapped as transport, network is marked as network, data link is marked as data link, and physical as physical. And here we will see some of the protocols and services that are used in each models. So let's take one example here. Let's say there is an application. Let's say that you are actually trying to access a web server. So now the application layer says, okay, for accessing the web layer, for accessing the web page, the protocol that you are going to use is HTTP. And how does that, how it does know? Because it will be coded in the application that for this application to use, I'm going to use HTTP. For example, let's say another application would be sending an email. So the email application says that I'm going to use POP3 or SMTP or IMAP for my service. So that's how it will be invoking those applications or services, protocol or services that this particular application actually uses. So let's take in this case the web server, and the web server says, okay, for at the client side it says, okay, I'm going to use the HTTP because that is, let's say you're actually opening the browser. For the browser actually works through the HTTP. Usually you can use browser for other thing as well, but in this case it will say that, okay, I'm going to use the protocol HTTP to access a server that is actually hosted in a data center, right? So it actually invokes the protocol HTTP. Now what happens then is it needs to use a specific protocol or service to present this particular data. Let's say you are actually streaming the video, or you are actually downloading an image. So the presentation layer tells that, okay, the image that I'm going to use is in IMG format or JPG format. So that kind of information will be fed in the presentation layer, and these are the protocol or services that will be used by that. It could be an HTML. You probably might have heard about HTML, the language that's been used to design the web pages, or it could be also saying that, you know, we are actually using the image as JPG format. Now with the session layer, we decide what is the, as I told earlier, it is going to use the synchronization and stuff like that. Also, if there is some sort of encryption that will be needed, then those encryption that is needed for the session, not for the data. Here you might have seen encryption. This is the encryption for the data there. Here is, but in the session, if it needs any encryption for the synchronization purpose and stuff like that, that will be used at the session layer as well. So it actually uses RTCP and PAP, but again, you don't need to really worry about presentation and session. At least for this one, you need to know about the application. So we'll talk about the application more, don't talk more about presentation and session, but do understand and remember that there are some in the OSI model, there is something called presentation and session layer, which actually used for the session layer is used for the synchronization and encryption between the session if needed, and the presentation is actually used to decide how to present the data when it is actually hosted and try to communicate to download it. Now from here on is the most important three layers. The first is the transport layer. The transport layer says, now I know this is the application that I'm actually using, and the protocol that I use is HTTP, and I have the image or whatever is the image or whatever content I want to download in certain format. Now what is the protocol that I'm going to use to transport this? That is actually done by TCP and or UDP. Depending on what you will not be using both, but you will be using one of the protocols, right? For example, HTTP and HTTPS always uses TCP, and the port number is 80 or 83. If it is HTTP, it is default port 80. If it is HTTPS, it is 443. So now once the application HTTP is being invoked and the relevant presentation and session layer protocol are invoked, it will take the service, the upper layer will take the service of the transport layer, which is actually TCP or UDP, and then say, you know what, this is the port number my application is actually residing. And at the client side, it will use a random port number, but at the server side, it is going to use the port number 80 if it is HTTP, 443 if it is HTTPS. And the client side, it actually uses a random port number. Again, we will dissect client side what happens, server side what happens separately, but do understand that At the application layer, if it is actually using a protocol HTTP, it is going to use at the transport layer TCP, and also depending on different other protocols at the application layer, different protocols at the at the transport layer will be used, either TCP or UDP. A simple example, another example is there is one more, one more uh, protocol called ICMP, which is actually used by the ping. Again, we will get into those things later. But the takeaway from this slide should be that at the at the upper layer model, at the upper layer of the OSI model or TCP model, the upper layer protocols will be using the services of the lower layer. Like HTTP is actually using the service of TCP. Now, what happens below that? Once you identify the application, make the content in whatever format, decide this is the protocol that I want to use. Finally, we go and use the next layer, which is a network layer, to send this packet in the TCP. We will be sending this packet which is in the TCP. We will make it in IP, and then we will actually send it across the network. So the job of the network layer is to route the packet in such a way that it actually reaches the end destination. So the network layer should be able to identify where it has to send the packet and how it can send the packet all the way to the end destination. And now, once that is actually happening, the next thing would be the data link layer. So now let's talk about the data link layer. The data link layer, it is concerned about the segments. Now, to understand what a segment is, let's say your PC or your device is actually connected to a cable, right? So wherever that cable extends, that is particularly called as a segment. To understand a segment a little bit more, let's do a simple whiteboarding. So let's say this is your PC, and let's say there are multiple PCs like this, and all these PCs are actually connected in one segment, right? So this PC will be connected here. It could be a hub, it could be a switch, that doesn't matter, but you will have all these pieces connected to one segment. So this particular part of the network is called as a segment. And what distinguish one segment to another segment? It could be a VLAN, or it could be something like a router as well. So now you have one segment here, and similarly you can have another segment here and another PC here. So let's keep those PCs here. So now this becomes one segment, and let's say this is a router, and this becomes one segment, and this becomes one segment. So the data link layer is only responsible for sending the packet from this PC to the end of the segment. So in this case, let's say this is PC1 and this is PC3. And if PC1 want to communicate to PC3, first this packet has to go from the PC1 to this particular router. And the data link layer helps the PC to forward the packet in the segment, and it knows that for it to go to the other end, the PC1 has to send the packet to the router. So this sending of it's called as a frame data at the data link layer, the packet is called as frame. The responsibility of the data link layer is only to send the packet from PC1 to end of this particular router, because then only it will be able to send the packet and route the packet to the PC3. So remember one thing, data link layer takes care of sending the frames in a segment, right? So that's what the role of data link layer is. Let's go back to the presentation. So that's about data link layer, and there are different protocols and services in the data link layer. The most famous is being Ethernet. There are other things like token ring and stuff like that. But do understand right now that the responsibility of a data link layer is to send the packet from the PC to, in that particular segment, it identifies where to send the packet to. And finally, the physical layer, which is responsible for the fiber and coax. Physical, basically, it talks about the speed, the link, what type of media it is actually being used and stuff like that. Now, one more thing that we need to remember is when there will be a client which is actually initiating the connection. So let's say the packet is generated from a PC and it is going to a server in our example. So when the packet is actually sent from a device, it actually encapsulate each of these data. For example, whatever it gets at the application layer, it gets encapsulated all those information in the application layer. In the transport layer, it gets encapsulated maybe in TCP or UDP, depending on what service it is used. Now, at the network layer, what happens is all the information from the transport and from the application get encapsulated in the IP. And similarly, when that information comes down, and then at the data link layer, whatever protocol we are actually using, the information that is actually encapsulated over the transport and network will get encapsulated in the data link layer. So when a packet is actually sent, what happens is this is how it actually happens. First, at the application, there is a data. And let's say for some reason the application is using the TCP, then what happens is the data is being encapsulated in the TCP. And at the network layer, what happens is it has the information about TCP and data, which gets encapsulated into the IP. And then at the data link layer, what happens is the Ethernet, let's say it's that Ethernet is a technology, then Ethernet encapsulate whatever it got as IP TCP. And finally, in the physical layer, it again encapsulated based on whatever is the physical media. And what happens when the packet reaches at the destination, it decapsulates it. So it strips out, once it gets the physical layer, it moves up to the data link layer. It strips out the physical headers or whatever trailers that has been attached. And then it goes up and then see that, at the network layer, it strips out the Ethernet. And then at the transport layer, it strips out the IP and the TCP, and at the TC and at the transport layer, it gets the data as TCP and then the data. And finally, at the application, it strips out the TCP headers and then it gets the final data. So at this sending side, it is encapsulation. At the receiving side, it is decapsulation.